We present a self-supervised approach to fit articulated meshes to point clouds. Our approach takes as input a 3D point cloud, which we show as a mesh for visualization, and a rigged mesh consisting of a template mesh and a joint hierarchy with corresponding skinning weights for LBS-based pose deformation. The goal is to learn a mapping from input point clouds to model parameters, but predicting only joint angles results in bad fit due to the modality gap, that is, the mismatch between the template mesh and reality. Therefore, we propose an encoder-decoder network which predicts a template style code in addition to the joint angles. The template style code is used to produce a deformed template mesh, which is then posed using the joint angles and LBS. The template deformation network takes each of the input vertices and the style code and produces deformed template vertices. This bridges the modality gap and allows estimating a more correct reconstruction and pose parameters. To make this work in the self-supervised setting, we need a good loss function. A popular choice is the chamfer distance, which computes pointwise nearest neighbors from the current estimate. But if the initial pose is wrong, this can result in bad correspondences. We propose a structured chamfer distance, which searches for neighbors only in the same group given by a segmentation. But how do we get the segmentation? For reconstructions, the segmentation is given by template skinning weights, and we can directly read it. For the input data, we train a segmentation network. We do this in a self-supervised way by perturbing inferred poses, which progressively get better, as well as sampling random poses. This is used as training data for the segmentation network. During training, we alternately update the encoder-decoder network and the segmentation networks. Here are some results from hand data. A folding net style approach obtains good reconstructions, but the topology is not correct and does not provide pose estimates. The 3D coded approach uses the right topology but struggles due to bad correspondences in the unsupervised setting. Our approach obtains good reconstructions and additionally recovers pose parameters. If we don't use the structured chamfer distance, the reconstruction fails to match, especially for complicated poses, as can be seen in the middle result. Here we show the segmentation component. Here we show the template deformation component.